Well, welcome everyone to the seventh and final seminar of this semester's version of our joint series with OPHI at Oxford, the UNDP HDRO team, and the Institute for International Economic Policy here at George Washington University. We're very much looking forward to today's session and delighted that you can join us, whether virtually or in person in Oxford. We're looking forward to hearing today from our dear colleague and friend, Suman Seth, and we will have some discussant remarks from Indranil Dutta before we turn things over. First, I would like to turn things over to my colleague, James Foster, who will provide some introductory remarks for our two speakers. James, over to you.
Well, howdy. I'm a little under the weather, so I'm ceding all the requirements for running the show to Kyle. But I wanted to put in a couple of punches here. First off, Suman Seth is known to me for some time. I knew him when he was a student because he was my student and the student of John Waymark, and at Vanderbilt University really shone among students. Since that time, he's proved himself time and again with new results, new insights, even to the point that they get into the Human Development Report and wind up being part of the perpetual publication machine of HDRO. So I really am pleased to see you again, Suman. We haven't talked in a while. We'll see each other this upcoming term, I'm sure. And next to him on my screen is this interesting character, Indranil Dutta, who introduced himself to me at one talk and then had me out to Sheffield, I believe, for a presentation back in the day. And in fact, we spent a great deal of time putting papers together and chatting about ideas. One of the few people who goes into a trance when you start talking about economic theory, and comes out of it with a paper written and published. So I want to thank both of you all for being here today, and I'm really looking forward to the presentation and the discussion. And of course, I see Sabina's there as well, so I'll just wave to Sabina and move on to sit on the sidelines. Thank you so much.
Fantastic. Thank you, James. So we're very much looking forward to hearing your remarks, Suman. We'll transition over to you, and please begin the presentation. The floor is yours.
Thank you so much, Professor Foster, for the generous introduction. I'm glad to see you, and thank you, everybody, for inviting me at the talk. So what I will do first, I will try to upload share my screen, and please let me know if you all can. Okay, good morning to my colleagues at IIEP. Good afternoon and good evening to my colleagues at OPHI. And good morning to my colleagues at HDRO as well. So this is a joint paper with Sabina Al-Khair, who is also present at today with us. And the objective of this particular study had been to come up with an approach to measure inclusive well-being changes over time, and we conduct multi-dimensional cross-country analysis linked to the global MPI. We have observed significant reductions in poverty and improvement in various well-being indicators over time. But of course, it is imperative to ensure that these global improvement in well-being and reduction in poverty is shared by all. It follows the UN pledge of not leaving anyone behind. Obviously, some sustainable development goals, such as SDG 10, requires reducing inequality both across countries and also within countries. And with that objective in mind, one particular SDG target within Goal 10 is to achieve and sustain income growth of the bottom 40% population within each country. And this goal relates to the World Bank's goal of following the growth rate of the bottom 40% and compare it to the overall average growth of the average income, which is known as shared prosperity. Now, this quantile-based approach, as argued by Kaushik Basu, it's a pragmatic application of the Rawlsian maximum principle, where it requires that we should be concerned about the improvement in well-being of the poorest person in the society. However, it's very difficult to identify that poorest person in a country. So one approach could be to, instead of looking at or trying to find out that poorest person, following or take a quantile-based approach where we look at the poorest quantile, maybe bottom 5%, bottom 10%, bottom 20%, and so on. And I think that's motivated the World Bank's shared prosperity approach of following the bottom 40% of the population, and whether their growth in income has been at par with the overall growth in income. Now, of course, it has been widely acknowledged that well-being and poverty are intrinsically multidimensional. And corresponding goal in terms of reducing poverty in SDG 1 has been to reducing poverty or deprivation in all its dimensions according to national definitions, besides taking care of the extreme poverty, which is extreme monetary poverty. Now, the non-monetary indicators of well-being, they typically have two common characteristics. One is that they cannot register unbounded increase like its monetary counterparts, such as income, consumption, expenditure. There's a strict upper bound, beyond which improvement cannot proceed further. And the other characteristic is that they can either be represented in terms of adequacies or in terms of shortfalls. Okay, examples could be, in terms of literacy rate, mortality rate, access rate, or they can be presented as literacy. Actually, adequacies would be survival rate. Sorry about that, and the opposite would be mortality rate. So either we could see survival rate as adequacies or mortality rate as a shortfall. In the counting approach framework, for example, we can either count deprivations or we can count equivalently attainments. And of course, Professor Foster and Sabine Alkad, they have a recent paper in 2019 where they actually show that how the results can also be obtained in the counting approach using attainments beside deprivations counts. Now, in this paper, what we do, we try to make a short theoretical contribution where we present a quantile-based framework to capture inclusiveness of well-being changes over time. And we build on absolute changes. And the key primary objective is to ensure consistency, which requires that the comparison of well-being changes remain unaltered, whether we assess in terms of adequacies or in terms of shortfalls. And our proposed framework is a bit more general than the SDG framework, which focuses on the bottom 40%. Now, that particular target would view bottom 40% as a homogeneous group, which may not always be true. Even different segments within that bottom 40% would have different levels of well-being, and progress among these groups may not be necessarily identical. It is possible that poorest of this bottom 40% has probably been left out. Now, how to observe that? So we make our proposal a bit more general in that sense. So instead of looking at that particular group as homogeneous group, we try to segment them into categories. For our empirical contribution, we apply this proposed framework to study changes or whether the changes in well-being has been inclusive or not for 80 developing countries. And we use a multidimensional well-being measurement framework, which is linked to the global MPI framework. I just wanted to point out that initial findings from this study, we started this study in 2019. Some of the initial results from this particular study, they were briefly mentioned in figure 15 of the Global Multidimensional Poverty Index 2019 report on eliminating inequalities. Let me now briefly present first the theoretical framework, and then I will present the empirical framework accordingly. So to start with, suppose we have two distributions of two periods. Distribution 1, we denote it by CDF, we denote it by F1, and the cumulative distribution function for period 2, we denote it by F2. Now, suppose this distribution can be divided into Q, capital Q, different quantiles, where quantile Q, capital Q, denote the richest one, and quantile 1 is the poorest one, and so on. Now, the average adequacy levels for the Qth quantile for period 1 is denoted by mu suffix Q F1, and that of period 2 is denoted by mu Q of F2. The overall adequacy level of each period, I just denoted by Fi, where I stand for 1 and 2, where the overall average, given that the population share within each quantile is just equal to 1 over Q, so we could compute the overall average as the averages of the quantile specific averages. Then the well-being corresponding to distribution Fi, which would be F1 or F2, is given by WFI omega, which is just a weighted sum of the quantile specific averages. Now, I'm not setting any restriction on these weights. We will come to these particular, what kind of weights, what kind of values these, we call it weight vector, what kind of value these weight vectors satisfy, quantile weight vector, we will come to that slowly. Now, we use this notation omega bar to denote a q-dimensional equal quantile weight vector. That means each element in that vector is just simply equal to 1 over q for all small q equal to 1 to capital Q. Okay, now we introduce some of the notation on changes. So change in the qth quintile, should be quantile actually. It's a quantile average, should be delta Q is equal to mu Q F2 minus mu Q of F1. Change in the overall average, we denote it by what's something called delta bar, which is the difference in the overall average. And change in well-being is denoted by the notation delta, which is simply the weighted sum of changes within each quantile, which can be, given their additive nature, this kind of particular decomposition is feasible. Now note, if I use omega bar instead of omega in the change notation, then for that omega bar, the change is simply change in well-being is the change in the average. Okay, this is how it should work. Now, let me provide a very simple axiomatic foundation. The first property that we require the change in well-being measure to satisfy is weak monotonicity. And we require that whenever all quantile averages increase or remain unchanged, the overall well-being should not fall. Okay. Then a second property, we refer to it as translation homogeneity, which requires that when all quantile averages change in the same amount, so does overall well-being. Okay, this is analogous to linear homogeneity in a relative world. And the third one is what we refer to as weak priority. All else unchanged, the same amount of improvement in a poorer quantile should lead to no lower improvement in well-being. So if we have, say, one particular distribution, and we possibly could go to two different distribution, two different timeline. In one timeline, we could improve a lower quantile average, whereas in another world, we improve a higher quantile average. The former one should lead to a higher reduction in welfare, a higher improvement in welfare. So this is the result that we get. So a change in well-being measure satisfies weak monotonicity, translation homogeneity, and weak priority if and only if we have this restriction on weights. Of course, each weight should be greater than or equal to 0. They all sum up to 1. And the quantile weight assigned to poorer quantiles should be no lower than the quantile weight assigned to the less poor quantiles. Okay, so this is the structure we get. This is the structure on the weight that we impose when we measure inclusive well-being. Now, by omega 0, we just set the quantile weight vectors that are characterized in proposition 1. That means they satisfy these three specific restrictions. Okay. Now we show some sort of decomposition, and that allows us to break down this overall change in well-being to an average change and a particular term that we are going to be referring as inclusivity premium. So this is the overall change, and as you can see, it has this change delta can be decomposed in what is called delta bar, which is the change in the average of two distributions, F1 and F2 over time. And then we have this additional term. So delta is the change in overall average, delta bar. And then A's can be broken down. This term A's is just the weighted sum of differences between delta Q and delta bar. Now this difference, delta Q minus delta bar, is the change in the average within the qth quantile compared to the overall change. So we are taking the weighted sum of the differences between each quantile average compared to the overall average. Now, when a well-being change is strictly inclusive, that inclusivity premium should be strictly positive. Now, what do you mean by strictly inclusive well-being change? A strictly inclusive situation would be whenever every poorer quantile registers strictly higher improvement than every less quantile. So suppose every poorer quantile, if we divide in 5 quintiles, for example, the poorest quintile should have larger improvement than the second poorest and the third poorest and so on. If that kind of situation occurs, then we should have inclusivity premium to be strictly positive. Now, what kind of restrictions then we require on quantile weights? Do we require some additional restrictions than what we have got in proposition 1? It turns out that the set of quantile weights that are necessary and sufficient for inclusivity premium to be strictly positive for strictly inclusive well-being changes would be the set that we have already obtained, which is omega 0, but it excludes the equal weight vector. Okay. So the set of all quantile vectors characterized in proposition 1, excluding this equal quantile weight vector, because that will not allow our inclusivity premium to be strictly positive, even when there is strictly inclusive well-being change. And this is the statement of the proposition that whenever we have a strictly inclusive well-being change, then we should have this particular restriction on weight that one lower weight on a lower quantile should be strictly higher than the weights on an upper quintile. It has to hold for at least one pair. Okay. Now, after that brief theoretical framework, let me show how our approach applies empirically. Okay, so we look at a multidimensional counting measure of well-being, which is linked closely to the global MPI. And for this particular application, we have a dual rationale. First of all, to assess inclusive well-being from a multidimensional perspective, going beyond the monetary perspective, and also to link it to the multidimensional poverty measurement framework. So for those who are not aware, most of us are aware of the multidimensional counting approach framework, but those who are not aware of the MPI, global MPI framework, there are 3 dimensions and 10 indicators. Dimension of health and education, each of them has 2 indicators each, and the standard of living dimension has 6 indicators. So first of all, the first step identifies deprivations within each indicator, and the second stage counts this number of deprivations, and a poverty threshold is set to identify those that are poor or not, and then the global MPI is computed from that particular framework. Now, we use multidimensional poverty measurement datasets for 80 countries, and thanks to colleagues at OPHI who harmonized the dataset over time, and we are using the 2020 global MPI harmonized dataset. For this particular application, our adequacy level is the attainment score at the individual level. And this attainment score is the complement of deprivation scores. Now we normalize these attainment score to be between 0 and 100, where 0 means the lowest possible attainment score or the largest possible deprivation score, whereas a bound of 100 means highest level of attainment score or lowest level of poverty or lowest level of deprivation score of 0 in that case. Then what we do, we divide the distribution of attainment score into 5 quintiles. Okay, so 20% population within each group. And then we use these following rank-based quintile weights. So the poorest quintile receive a weight of 5/9. The second poorest quintile receive a weight of 3/9. The third one receive a weight of 1/9. And we do not assign any weight to the 4th and 5th quintile for this particular exercise. Yeah, so the poorest quintile receive the highest weight of 5/9. The second poorest receives the weight of 3/9. The third poorest 1/9, and that's it. Okay, so how do changes in these 80 countries look like? Let me take some time to interpret the results in the figure. So on the vertical axis, we present the annual change, annual absolute change in well-being. Okay, our well-being is just an additive measure. So once we compute them and we look at the change, annual change in well-being in absolute term, we observe that of these 80 countries, 70 of them observe, 77 of the countries show statistically significant absolute change, statistically significant absolute improvement. Okay. Benin is the country which showed statistically significant deterioration in well-being, and 2 countries do not show any statistically significant change over time according to the well-being measure. Now, we have selected a particular weight, and one may ask why only this particular weight. There could be other weights as well. So what we do in the paper, that what I'm not going to be presenting today, we also develop a framework for checking robustness with respect to different weights, and that framework builds on my work with Professor Foster and Mark McGillivray on robustness of checking robustness of weights for composite indices. We use the same framework to develop a robustness test mechanism, and we check those check the robustness with respect to these different weights, and we show that all changes here, you can see, except for these 4 red dots, circles, 4 red circles actually, except for those 4 countries, all other improvements or deterioration for Benin, they are all robust with respect to all possible weights that satisfy the restriction, that satisfy our restrictions in proposition 1. Yeah, so we can see there are for 76 countries, we have robust, statistically significant improvement, or for just 1 country included there, 1 country we have statistically significant robust deterioration. Okay. Now, so for most countries, we observe improvement in well-being. Now, what do we observe when so these are the countries in square red that do not show improvement. Others all show improvement over time in well-being. Now, when we look at the inclusivity premium, the picture is slightly different. Now, we observe that there are several countries actually which show statistically significant negative inclusivity premium. Okay, so inclusivity premium is negative when upper quintiles have registered larger improvement than the lower quintiles. Okay, so if the average in upper quintile increased more than the average in the lower quintiles, then inclusivity premium can be negative. So out of 80 countries, only 60 countries show statistically significant positive inclusivity premium. That means for these 60 countries, we observe that well-being increase has been inclusive. For the rest of the 20 countries, either we observe negative inclusivity premium or no positive premium. That means they're not statistically significantly different. Let me discuss some of the highlights from these inclusivity premium analysis. So no statistically significant positive premium for 20 of the 80 countries. Inclusivity premium is between 0 and greater than 0 and up to 0.25 points for around 25 countries, greater than 0.25 to 0.5 points for 24 countries, 0.5 to 0.75 points for 8 countries, and 0.75 to 1 point for 3 countries. These are the countries, 11 countries for which the inclusivity premiums are statistically significantly negative. That means we cannot say that well-being has been inclusive. Rather, it's the other way around for these countries. Now, we conducted some region-specific analysis, and I wanted to share some of the findings from sub-Saharan Africa. So we had 35 countries from sub-Saharan Africa, and 17 of them do not produce any statistically significant positive inclusivity premium. Also, the inclusivity premiums are negative for 11 countries, and 10 of them are from sub-Saharan Africa. I'd like to mention here, and also actually thanks to Sabina, that we did not conduct any analysis based on the population size that we are covering, mainly because they're from different years, and there is no correct techniques of summing up population from different years. So we focus at, for this paper at the country level analysis. I wanted to share also, just to get some intuition about what these changes or this inclusivity analysis mean. We look at we compare the cases of India and Nepal, and we look at changes over here. So if we look at India and Nepal, both had similar per annum improvement in the overall well-being based on the weights that we have considered. For India, it's 1.86. For Nepal, it's 1.9. Very similar. When we look at the change in the average attainment scores for these two countries, for India, we observe it to be 1.39. For Nepal, it's 1.23 and per annum. And this difference is statistically significant. Then we come to the inclusivity premium value. There we see a switch. Actually, Nepal's inclusivity premium is much larger compared to that of India, and that is statistically significant. So we can see the similar change in well-being based on the particular weights that we have considered. But when we break it down into two components of change in the average and whether it has been inclusive or not, we see quite a different picture. What I will do in the next slide, I am going to present these, here I presented just India and Nepal. In this particular graph, I present all 80 countries. And how or whether we see any particular pattern, particular trend. Again, just to remind you that overall change delta is the sum total of the change in the average plus this value of ACE, which is inclusivity premium. Now, this particular figure where on the vertical axis, we have inclusivity premium per annum. And then on the horizontal axis, we have change in the average attainment score per annum. The overall value, actually, the overall change in well-being is the sum total of these two coordinates. Okay. So you can see here that India, let me see if I can use my, no, I cannot use it actually. I do not know how to, can you see my cursor? I'm not sure how to show it. Anyways, if you see here, India, which is the circle, the second largest circle after China, and then on top of India, there is Nepal. So you can see the example that I just presented. So if you sum these two coordinates, they both should sum to around 1.86 and 1.9, but you can see the difference where one has higher inclusivity premium than the other one. We also took the opportunity, and it's data permitting. We could not match all data points with World Bank's shared prosperity premium, which is the shared prosperity premium is an index consisting of the growth in the bottom 40% of population's income compared to the overall growth rate. It's a relative measure. And we were able to match 25 countries. And our criteria for matching has been that either the first years or the last years are within 3 years apart from each other, so as to provide us a better, more meaningful comparisons. When we compare across these 25 countries, of course, we are comparing relative with our approach, which is more absolute. We observe an inverted U-shaped relationship overall. So we could not say that we have a particular increasing or decreasing relationship. An obvious candidate, of course, to compare our inclusive well-being analysis would be the global MPI, because the well-being measure that we use for inclusive well-being analysis is the global MPI framework. So how do they compare? Again, we expected, so we have absolute change in global MPI per annum on the vertical axis, and we have inclusivity premium per annum on the horizontal axis. We again do not observe an increasing or monotonic relationship. Somehow here also, when we plot and we take the population weighted as well as population unweighted polynomial fit, we observe again an inverted U relationship. So of course, we are wondering what could be driving this particular type of nonlinear relationship. So we look at two particular countries closely, Tanzania and Zambia, both from the African continent. And they had similar reduction in MPI per annum over this period. For Zambia is between 2007 and 2014, for Tanzania is between 2010 and 2016. And also they had similar kind of per annum reduction in the incidence. So the MPI went down by 0.012 for Zambia, 0.011 for Tanzania, and similar reductions in the multidimensional headcount ratio per annum. So 1.7 percentage point for Zambia, 1.9 percentage point for Tanzania. Of course, if we look at the intensity, which I have not presented here, one intensity has gone down much further than intensity of the other country. When we compute the inclusivity premium, however, for Zambia, it was strictly positive. That means Zambia's progress over time has been multidimensional progress in well-being. For Zambia has been inclusive, this strictly positive premium. For Tanzania, it has been statistically significantly negative. Okay, let me show you in terms of the figure what has happened. So here we present bar diagrams. We have 5 quintiles, 4 is 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. 80 to 100 is of course the richest quintile, and then about poorest 20% is at the left. And these black, the darker shades actually on top of the lighter shade, they show the change or improvement in the average for that particular quintile. You can see for Tanzania, it looks like a lot of improvement has taken place in the top 2 quintiles. Bottom 2 quintiles did not register much improvement, despite similar poverty reduction. In Zambia, on the other hand, if you look these steps, the darker shades, those are the change or improvement in average within each quintile. You can see is much larger compared to in the bottom 3 quintiles compared to the 2 richer quintiles. So you can see that despite similar multidimensional poverty reduction, if we try to understand whether in one country the progress has been more inclusive than in others, you can clearly see in Zambia, the similar multidimensional poverty reduction has been inclusive, whereas in Tanzania, it has actually not been inclusive. So it adds some value on top of the global MPI analysis. Okay, so I will try to wrap up the discussion. So again, the objective was to create a framework which is similar in line of the shared prosperity analysis, but to understand whether we can create a multidimensional framework to study inclusiveness of well-being in a multidimensional framework. And so we developed a framework which is closer, very closely linked to the global multidimensional poverty index framework. Now, the theoretical framework that we developed, it is not just, we set the example for just 5 quintiles, but of course, it can easily be extended to study changes in a larger number of quintiles. It can also be used to study and analyze inclusiveness of well-being within countries. For example, one analysis we are thinking if we could have is to study whether the large reduction in multidimensional poverty in the Indian context recently, whether it has been inclusive for all states or all districts or not. It would be a good example to conduct similar kind of study within other countries in order to understand whether some policies in some provinces has been more inclusive than others. And our framework is also equally applicable for any other bounded indicators of well-being, which has sort of an adequacy and shortfall representation. Thank you so much. I will stop here.
Thank you so much, Suman. That was a fantastic presentation. Let's turn it over now to Indranil Dutta for the discussant remarks. For those of you in the audience, I would encourage you to begin formulating your questions if you've not already. You can use the Q&A function at the bottom of the Zoom screen to submit those questions. And for those in the room in Oxford, you can simply raise your hand to alert Kellyanne to your interest in asking a question. Indranil, we will transition over to you now.
Can you see my screen?
Yes, we can.
Okay. Fantastic. So when I read this paper, I really liked it. So, and although this was a last-minute request from Suman to discuss this paper, I think you'll see that I'm able to, or I have been able to get to some of the core ideas in this paper. To summarize, the two. This paper is super interesting because it provides you both the theory and the empirical part. And in the theory, this is a quantile-based comparison of well-being. And well-being here is based on a bounded indicator. There is some role of this indicator, the fact that it is bounded later on, although Suman, I think in the presentation did not mention it very clearly. So here the bound is, consider it any bounded indicators between 0 and U. And well-being is simply a weighted sum of the average attainment in each quantile. That is what well-being is being defined as. So if you have the attainment for each quantile, just take the weights, and the whole play here to some extent is on the weights, and I will explain that in a moment. Particularly, lower quantiles get higher weight. That comes from some of the axioms that is presented in the paper. The novel part, I thought, was the fact that it introduces a new concept of inclusivity. And you saw in the presentation, particularly on the empirical side, that you can get great insights using this notion of inclusivity, what they call as inclusivity premium. And there is a link to the robustness of weights also in the theory part, linking how you can test for the robustness of weights based on the papers of Suman, Mark McGilvray, and Professor Foster. And it also includes some adjustments for bounded variables. In the empirical part, it's a very detailed and thorough work. So, amazing effort from both Sabina and Suman on this. Excellent work. 80 countries over 2 time periods. I mean, they have 2 time periods, but essentially within the countries, I saw that the time periods are not the same. So they have taken the average, I think. So for some countries, the difference between the 2 time periods is, say, 10 years. For some, it is 5. So the difference is being divided by 5 by the total number of years. And well-being here is typically the complement of a deprivation score, and the deprivation score could vary between 0 and 100, and so the well-being is the 1 minus the deprivation score, if I understood it correctly. And the analysis is based on quintiles. The quintile weights is 5/9, 3/9. So this is the lowest quintile gets 5/9. The second lowest quintile gets 3/9, and then middle quintile 1/9, and 0 and 0. So by design, you can see that the focus is on the bottom 60%. The way the weights have been taken into account. And I found particularly the nonlinear relationships with some of the other indicators like the shared prosperity and the MPI quite interesting. And so it brings a lot to the table, this paper, and it's super interesting. Now, my comments will be based on 3 areas. First, on inclusivity. So what is a reasonable definition of inclusivity? And second, on bounded variables, how do we adjust the bounded variables? And finally, on the empirical application, particularly the role of weights. So when we think about inclusivity, the whole idea in this paper, at least in my understanding, seems to be that lower quintiles should matter more than upper quintiles. So changes in the lower quintiles matter more than the changes in the upper quintile. But the way the weights, the axiomatic structure is there, and the weights are being assigned, I'm not sure whether it is actually capturing the notion of inclusivity, or that perhaps both Sabina and Suman wants to capture, or perhaps something that we have already seen in the literature with respect to pro-poor growth and of Kakwani, and I think James Foster also has some work on this, although I'm not sure it is published or not. So the reason for that is the following. I'll give you an example. So I'll start with the second part. You can see the weights of the quintile. So this is a quartile now. So I've divided the whole population into 4 parts, and so my weights are 0.5, 0.25, 0.15, 0.1. And country A, the change in the mean attainment in the quartiles are 0, 0, 2, 2. So this is the change in the mean of the quartiles. And for country B, it is 0, 0, 1.25, 3.75. So country B overall, the average for country B, country A is 1 over the 4 quartiles, and for country B, it is 1.25. Now, SA and SB are the inclusivity premium. And in my calculation, what it is showing is that SA and SB are both the same. Maybe this is something that Suman can correct me later. But what it shows here clearly is that look at how the distribution is for country A and country B. Country A, it is more equal than country B. Whereas if you take the inclusivity premium, just the inclusivity premium, the way the formula is, then you will see, okay, I may have made a mistake. I can see that where the formula that I may have made a mistake, but you'll see that, and I can play around with it, and I can show that at least there will be some matching of the inclusivity premium. So the inclusivity premium is not really telling us the whole story here, the way we want to capture it. Okay, and yeah, so a little bit around the weights, I can work this out and change the story. So right now I can see there is a slight inconsistency in the way I have done it, but I can play around with it and perhaps be able to match the same story here. But with the weights, the way it is currently given in the paper, so take point number 1, which is weights is 0.4, 0.25, 0.25, and 0.1. immediately you can see if the changes are happening in the second or the third quartile, there will not be any difference. So same changes happening in the second or the third quartile, because the weights of the quartiles are the same, you will not be able to know where the changes are happening. And that is because this weight in part 1 is allowed in the paper. So within the axiom system, that kind of weight is allowed. The second point that I wanted to mention was about the bounded variable. So the bounded variable adjustment that is being made is the change in the welfare would be divided. So F and G are the two distributions, and W is the fixed weights. And what you do is you divide it by U is the upper bound of the bounded variable minus the welfare in the previous period. So imagine F is the initial distribution in the initial period, G is the distribution in the next period, and so you divide it, the change in welfare divided by the difference, the maximal difference. This is the justification for taking this U minus WFW is the fact that it's the maximal feasible change in well-being between the two time periods. That's at least what is written in the paper. Now, the maximal feasible change could also be WFW minus 0. So this one, that U minus WFW, may not be the maximal feasible change that is possible. And so I don't know how you adjust in that case. And my third point is on the role of weights. So weights is playing a little bit of story here, particularly in the empirical part. I did not understand why those set of weights were chosen. How do you arrive at it? Should this be like, somebody wants to undertake a similar kind of analysis, say over deciles, then what should be the weight? And is there a kind of system to think about that? And finally, in many cases, I saw that the robustness conditions, particularly with the weights, were not satisfied. Then how do you make comparisons? Do you still, if the robustness conditions are not satisfied, then given that this is just based only on one weight, can we say that Nepal is actually better than, I don't know about Nepal, whether I don't know whether the robustness conditions are satisfied or not, but in case it is not for at least one country, say for India, if it is not satisfied, or for Nepal it is not satisfied, then can we make any valid comparison between Nepal and India? Thank you.
Thank you, Indranil. I will first turn it back over to Suman, as well as to Sabina, if she would like, to respond to Indranil's comments, and then we will open up to the floor. Suman, over to you.
Thank you so much. Sabina, is that okay if I respond to the comments first?
Yes, that's fine.
Okay, thank you so much. Thank you so much. You had such a brief amount of, short period of time. Even then, you were able to read the paper and came up with or gave this useful feedback. So first of all, thank you very much for that. Really appreciate it. Let me try to respond some of, rather the 4 points that you raised. They're interesting points. The first one, the weight example that you gave, I think it's sort of, going from transfer principle to transfer sensitivity. Because what we have done, we have tried to show whether the priority principle that I just showed, or just said, if we have same amount of improvement in 2 timelines in a poorer quantile versus a less poorer quantile, this should be preferred. That's it. We did not say the amount, or I.M. Gaston in another paper, which was published in World Bank Economic Review, where we're dealing with ordinal variables, where we tried to show, whether that improvement is taking place in consecutive categories or consecutive percentiles or jumping percentiles. That's completely a different theory. So we have not gone that far. So that it possible could be that is what is driving. So what you will do, probably you will require further restrictions on weights, which I have not done. So I have just stopped there. So the restrictions we got will be very much analogous to a transfer principle type of approach, not going to transfer sensitivity or higher degree of changes. It could be because of that, potentially, but I'm happy to talk to you and I'm happy to look at the example that you provided. The second one was maximum feasible. And that's something we are working on. Actually, Sabina pointed out something very interesting over there. So my objective, my idea there was, you know what, you can have, first of all, the formulation that I came out and the alternative formulation that you provided, there's a slight difference. The one that we came out is the absolute change, but we are just looking at the absolute change as a proportion of how much maximum change we could have, right? Here, more is better. Here is not, you know, for in the poverty dimension, in the poverty world, it's less is better. Here, more is better. So we are increasing well-being, but then if we could go that far, in proportion to that, we are coming up to here. Now, what you are suggesting, your W, given that you did not add 1 or 2, I was not sure which period you are referring to, but possibly you are referring to the initial period over there. So am I correct in saying that your when you are dividing, the denominator is actually the level of well-being? So it is you are looking at the relative change. So if you look at the relative, sorry, you wanted to say something?
Only thing is that we are looking at, you know, shortfalls too. So it's not just progress, but how much it can fall also, and that it can fall to 0 too, right?
Right, the other side of it.
Yeah.
What Sabina observed, you know, that U minus the level of well-being, that that shortfall that I'm talking about, if you look in poverty world, then that particular interpretation becomes relative fall in multidimensional poverty. This is something that Sabina pointed out, and we are working on it, how to best bring it there. But what you are trying to say is that if it is falling, how much maximum it could fall, something like that. It depends on if you are looking study, because then that particular value will be positive as well. You see, so we do not know whether we want to go to that world or not in that sense. But that's an interesting point. I'll think about more. And if Sabina has something after me, Sabina can also add. Role of weights is quite important. So of course, we have these restrictions that where we have lower quintile should not get any lower weight than the upper quintile. So that's the restrictions we have. Okay. So we selected one particular set of weights among many alternatives, and this is an issue in any well-being measurement, whether we do composite indices, whether we do multidimensional analysis, weights and checking robustness with respect to that weight, because any weight we come up with, and this is I and Professor Foster had worked a long time ago as well, any weights we come up with will have some sort of sense of arbitrariness, and that's where the robustness part comes into play, and that's the reason why we added that theoretical part. And now the fourth concern that you raise is very difficult to answer, and maybe Sabina has some answers Sabina could provide. I mean, if it is not robust, and if we believe that we should go to that extreme form of robustness, of course, we cannot make any conclusion. However, the framework that I presented, we could, if we want, as I and Professor Foster, we also tried earlier, if we want to check the robustness for a smaller set, it is also possible. And of course, if we do check the robustness for a smaller set, we will get much larger number of comparisons. Okay. For this particular paper, we tried to go to as extreme as possible to check whether, you know, these comparisons are robust to the fullest extent of, and crucially, the thing that I did not present, we had one extreme weight as 0.5-0.0.0. That particular weight gives us a direct measure of bottom 40, because we are assigning, yep, so that particular weight. So, you know, what I could not present, that checking robustness is actually gives us a generalized Lorentz framework, where we are checking, comparing the poorest quintile we are comparing the average of the bottom 2, we are comparing the average of the bottom 3, and so on. So it's kind of a generalized Lorentz framework that gives. Now, if we cannot compare with Lorentz comparisons or generalized Lorentz comparison, I would like to hear also from you and Professor Foster, what do we do? Do we, what kind of other criteria would like to go? Okay, or we just say, we cannot compare. Sometimes it is probably going in Professor Sen's, Amartya Sen's word, sometimes it is probably good to say we cannot make any comparisons, rather trying to, impose a particular complete ordering. I don't know. It's a divided world in that sense. Sabina, if you want to add something, sorry.
Thanks. I think, again, thank you so much, Indranil. That was really, really useful. And I think it's helped to clarify things that we do need to clarify in terms of limits of what we're trying to do. I think just to your last question about partial orderings, what we're doing is we're taking the uncensored vector of attainment scores. So 1 minus the deprivation score uncensored. And so if we can't compare, the growth of that in terms of these metrics, then I think describing it is what you can do. But in terms of these metrics, it really is a question of whether you can say there was a particularly defined kind of pro-poor growth. And how, of course, that's defined is interesting. But if you don't have it, then you have to say, no, that's new information that we don't have it. We can still look at, that distribution and see what else we can say about it. But inequality measure, you can do all sorts of things with it, but you have to say it doesn't satisfy this. And so I think that it's a little bit humbler. It's ratcheting down the expectations, but it is saying that we're just trying to nail one particular kind of relationship between the quantiles.
That's fine. I think, James is asking questions. So yeah, I'll hand it over. Thank you very much. Thank you for your response.
Great. Well, I don't want to jump on anyone in case someone has a chat question, but let me throw a couple of things in. First off, since we're dealing with cutoffs here in quantiles, you commented on the equal weights across 2 different quantiles and how that is right on the margin. Actually, within quantiles, all weights are equal. So therefore, for a large swath of the entire thing, you have equal weights. It is not emphasizing the lowest. It's emphasizing the same way as the shared prosperity does, which is a bit vague in terms of looking at the lowest, but it does so on a grand scale of, if you look at the lower 40% compared to overall, that's an inequality measure. It's rather crude, but it gets to the point. The other thing, the discussion between absolute and relative here is really of interest to me. Inclusive growth, the way I've always thought about it, has something to do with relative. Seems that way to me. It doesn't have to. It could be absolute as well. There's also modified by something else. Something else is changing. Let's say incomes are going up. Well, per unit of income, how effective are we in achieving certain results? And so something on the bottom relative to the bottom, the growth rate in income, let's say, is a useful way of making things comparable and clarifying what's going on. So my notion of inclusive growth usually uses that. Yours, I'm not so sure here. General Lorenz, of course, generalized Lorenz is at least floating around the picture here, not precisely, because you're dealing with quantiles as opposed to individual observations. But all this stuff is, 100% relating back to that, relating back to Tapan Mitra's in my paper, relating back to all the kinds of ways that you change weights, and it emphasizes certain aspects of a distribution. I think that's that I think is quite interesting here, and it's a great additional example of what's going on. I do think that using the measure to see how robust you are is a nice thing, to the extent you can. So if you could use a measure, it would be useful. You could say, why goodness, this is 90% robust, or 2% robust, and that makes it a little bit more than just saying, well, it isn't robust. And well, yeah, but is it not robust because there's a large number of weights that could screw it up, or there's very little weights that could screw it up. Finally, I can't help but think about the Ahluwalia-Chenery Welfare Index. That's also is based on quantiles and also based on weights, and is used for quite a while in the income-based approach. How does this relate to it, and do you link this and do you contrast it with it? It would be really great to know. That's my questions.
Can you hear me, Professor? Yeah, thank you so much. Starting with the last one, we have not checked actually the Ahluwalia-Chenery Index. I have to go in details and check, and I will get back to you on this. So I don't have a direct answer to that question. For the robustness, measure of robustness, again, it takes us back to our own work at some point. Hopefully it gives us another incentive to try and have a goal and to finish that piece, which we tried, we started trying to measure robustness. I will again try to revisit that. It's looks like it's just an interesting thing to be able to finish. I will also look at your paper, Mitra and Foster, and also that's a very interesting thing that you just mentioned. I have to go and check how things relate to that particular aspect, where you discuss different and whether we can make it fit in that particular framework. The absolute versus relative. Of course, here, mainly because of the consistency. For example, whether we do it in the inclusivity premium approach in terms of attainment score or in terms of deprivation score, generally in this particular approach, we will get the same result. Same inclusivity premium and so on. And that's something in the relative world we may get lost. So that was one reason why we sort of tried to focus on this absolute world. So I think those are the answers. And for the GL approach, yes, I completely, it's a restricted one. When I use the generalized Lorenz approach, it is not because it was based on all of them. Because sometimes for Lorenz curve also, we can take some of the points and we can create that kink Lorenz, right? So we will have a kink generalized Lorenz world. But then, of course, it's quite nicely linked, because here, when we do robustness check, we had this entire hexagon or triangle kind of thing in our world, right? Here, it's just one corner. Okay, and when we do that, we have this 1/3, 1/3, 1/3, then half, 0, and then 1, 0, 0. So it's just like putting all weight here on bottom 2, on bottom 3, and so on. So it's quite nice in that way. It adds to that kinked generalized Lorenz kind of framework, okay, which we try to link, of course, your work with Tony Shorrock and others. Yep. Thank you.
Great. Sabina, would you like to add anything in response to James? If not, I will turn the floor to Jakob.
I think Jakob, for time, my internet went down when James started to talk.
Sounds great. Jakob, over to you.
Yeah, hi all. I hope you can hear me okay. Thanks, Suman, for fantastic presentation. Great paper. Also, thanks, Indranil, for the discussion. So 3 quick questions. The first one, I think, just in terms of, the inverse of the global MPI as a well-being measure. So I wondered if you could say a bit on that, because basically we have the absence of insufficiency there, right? But that's something different than a well-being measure, one might say. So I was wondering if you could talk a bit about that also, because that might make the comparison with something like the World Bank's growth of the bottom 40, just by virtue of what they're measuring in terms of growth, a bit more difficult. The second one on the quintile partitioning. So I'd just be curious how that worked out, because I imagine that quite difficult actually for something like the counting scores or the inverse of the counting scores. So I was just wondering how exactly that played out empirically. If you could comment on that. And then the last bit, just, Suman, you mentioned the motivation behind basically what you were here trying to do, and also, behind what the World Bank is doing. They're doing something very crude along those lines. Now, doing quintile-based maximum is, a communicable headline, basically. But so I was wondering if that is also the motivation for your paper, really, if, going a bit more granular and going more towards something that would look at differences. Similar to what Indranil and James also said already, to explore that intuition with a bit more depth, basically, if that's the next step, or if you've already explored this. Yeah, thanks.
Thanks, Jacob. Sabina, would you like me to go first, or you'd like to add something?
Yeah, you can go first and I'll then wrap it up.
Okay. Jacob, first one, I will answer again from your last question onward. So in this paper, and as Professor Foster also correctly pointed out, that in the end, we are focusing on quintiles. But then Kaushik Basu argued, in a world we would like to identify the poorest of the poorest person, but it's also based on a survey. So it may not be practical to be able to go and try to identify. Rather than that, we identify different segments. Yeah. So it could be it could be even bottom 1%, bottom 2%, bottom 3%, and so on, something like that. Yeah. And then weight them accordingly to create a measure. So for this paper, we did, just to show the application, we used these bottom 20, then next 20, next 20, and use these ordered rank-based weights. And as I was telling, responding to Indranil, that one weight could also be half 0.000. Now that half 0.000, we use it for robustness test at one extreme weight, but that is exactly the same weights as World Bank shared prosperity. So in future, if I, Sabina, and colleagues at OPHI, if we have to generate something for future, we can use that weight as well. That will give us exactly the improvement among the bottom 40% of the population. It will be directly comparable to World Bank shared prosperity approach. But of course, there will be relative, our will be absolute. Yep. Then very interesting, very good question about empirically how we did that quintiles. Yep. Look, first of all, I should mention that our approach, and that's why we did not discuss, this approach is not kind of decomposable across population subgroups. So if we are applying it at the country level, it should be applied at the country level. And within different states, provinces, however we do it, we should apply it separately, not try to use the same ranking because that will distort everything. Okay, so what we do, first of all, for empirical analysis, we rank all the deprivation scores, right? Now, it is possible, because there will be some sort of discontinuity in that sense, same deprivation score can actually fall into different quintiles. Okay, now there you can take an empirical approach. Which of them should be assigned to, say, bottom quintile? Say you have a deprivation score of 0.3, or an attainment score of 0.3, which is deprivation score of 0.7. And they may fall also in the bottom, some of them may fall in the bottom 20%, some of them may fall in, let's say, 20 to 40% quintile. Now, the approach I took is that I created a random number so that I do not select specifically how I want them to be distributed, but I select a random number with a particular seed so that these results are reproducible. And they assign, that random score assigns who should go in the, say, bottom 20% and who should, with the same score, come in 20 to 40%. Yeah. So, I mean, wherever they go, actually, in the end, it should not matter because it's the same score. Okay. And you will have the bottom average and then the 20 to 40 average, 40 to 60 average, and so on. And you will still, at the end of the day, will check how it is improving over time. Yeah, so that's how I have done empirically. It was a kind of challenge, but that is a way around that I found. And of course, your results are not going to change with each replication. They will exactly give you the same result. Yeah, every time you replicate. Inverse, the attainment score as an inverse. I mean, look, as I tried to say, that our objective was to find something that is comparable to the global multidimensional poverty measurement framework, but at the same time addresses the issue of inequality within countries. So that was the objective, the twin goal, to fit them in the same framework. I mean, that is how we started in 2019, the way that we would use this framework to find something comparable to World Bank's approach, but from a more multidimensional perspective. I'm not sure if I answered the first question properly, but please let me know, or Sabina, if you want to add anything to Jacob's question.
Yeah, I think this paper, the empirical example is illustrating, and it's illustrative. And it's true that the MPI framework is of acute poverty, and so the inverse of acute poverty might not be well-being. But I think that the conceptual framework of having cutoffs is useful, because in a constrained policy environment, policies can only create certain conditions, and there will be human diversity in people's aspirations to enjoy greater than the basic conditions in different variables. But if one possibility of a well-being measure is to actually clearly fix that this is sufficient, beyond that is a matter of personal choice, but this is, you know, the right, or this is the degree to which policy must support all people to obtain this level of attainment, if it's an uncensored vector. So we're not talking about a critical mass, but just in every single indicator. So I think that is the conceptual route to be fleshed out, whether with these indicators and deprivation cutoffs or another set.
Fantastic. Well, I think we are getting close to our stopping time. So unless someone has a burning question, I would like to thank Suman and Sabina for a fantastic paper, and to Suman especially for his presentation, and Indranil for your remarks. Thank you to all of you in the audience for joining us both today as well as for previous iterations of our series. And please be on the lookout for outreach from IIEP, OPHI, and the HDRO team around future seminars. And with that, I hope that you have a wonderful rest of your morning, afternoon, or evening, depending on where you're located. Take care.